Okay, question 3. Considering following statement about the positive integer n. If n is prime, then n squared plus 2 is not prime. Which of the following is a counterexample to this statement? Okay, good. So if we want to find a counterexample for an if-then statement, what do I need? I need this to be true and this to be false for a counterexample, right? Because if you think of the truth table of if you think of the truth table of A implies B, then if A is true and then B is true, then you're good, right? Then you're good. If A is true, B is false, then you're bad, right? And false implies true is also okay, and a false implies false is also okay, right? So it's just this is just like a logic gate, right? Your AND logic gate, OR logic gates, XOR logic gates, implies is also a logic gate. You can draw a truth table for it. Yeah, so the truth table is there. I have quite a story to memorize this. So imagine, okay, this statement, 3 equals to 5. Right, so this is false statement. I hope we realize that this is a false statement. Okay, but using this statement, I deduced that 5 equals to 3. Which is also false, right? Which is also false. But this implication is okay, right? False implies false, this is okay. Right? Because 3 equals to 5 would imply 5 equals to 3 in mathematics, right? That's nothing wrong there. Okay, so false implies false. I've shown you the last option here. Okay, now using these two false statements, 8 equals to 8, right? Because if I add up the two equations there, 8 equals to 8. Which is a true statement. This true statement followed from two false statements. So I've shown you false implies true. That option then. Okay, how do I show you the last statement? Well, I'm going to add, add 2 to both sides of the equation, such that 10 equals to 10. This is also true. Right? So I got a true statement from a true statement. Right? All of these are implies, by the way. So true implies true is also okay. So I've shown you all the 3 possibilities of implications. Yeah. So the counterexample we need is if true, then false. Yeah. So therefore, in the context of this question, if n is prime, then n squared plus 2 is also prime. Right. Okay. So let's have a look at the options. So which option is already silly? Well, I can see that n equals to 4 is already silly, right? Because n equals to 4 is not prime. So that destroys the first true requirement. Okay, so 3 would not be a counterexample. Okay, but then what is n equals to 2, for example? N equals to 2 is prime, great. So I'm going to check n squared plus 2. So 2 squared plus 2 is 6, right? That is not prime. So that actually supports the statement. Yeah, so 1 is also no good. How about option 2? When n is 3, okay, 3 is prime, great. And then 3 squared plus 2 is 11. Yeah, so 11 is prime, right? So that's a counterexample to the statement, as I told you just now about the truth table. So 2 is correct, is a counterexample, so option C.